Dear children, we were discussing about the valency of the elements and how to find out the valency of the elements from the periodic table. In the modern periodic table, the elements belonging to group 1A and 2A are normal elements. 3A, 4A, 5A, 6A, 7A and 0 group in the extreme right of the periodic table, they are called normal elements, and these are the normal elements. In the long form of periodic table, there is a group 1A and 2A. They are called as S block and they are called as P block according to their electron configuration. So as I told you that in the whole periodic table we have here S block. In the extreme left we have 1A and 2A. Then we have here P block. In the extreme right we have 3A, 4A, 5A, 6A, 7A and 0 group. So if you go to the long form, it is 18, it is 17, it is 16, it is 15, it is 14, it is 13. 10 plus 3 is 14, 10 plus 4 is 14, 10 plus 5 is 15, 10 plus 6 is 16, 10 plus 7 is 17, 10 plus 8 is 18. So see how nicely the periodic table is there. And this is 1A and 2A, this is group 1 and this is 2A, they are group 2. Now in between you have, this is 3A and this, in between this we have the D block of the periodic table. So here the electrons are placed D group of the periodic table, and these elements are called as transition elements. These elements are called as transition elements. And all these elements are highly electropositive metals. If you come to metals, if you come to modern periodic table 3B, we have 3B, 4B, 5B, 6B, 7B, 8B, then 1B and 2B according to modern. But the moment you come to long form, 3B is called group 3 and 4B is called 4, 5B is called 5, 6B is called 6, 7B is called 7 and here 8B, it is 3 divided into 3. So there is 8, 9, 10 and this 11, this 12, then 13, 14, 15, 16. So my point is, because I want to teach you periodic table, from periodic table the valency, I am taking the periodic table, modern periodic table. I am talking to you from modern periodic table, never confuse from the long form of periodic table. Now they both are same, modern periodic table and long form periodic table is same, but here they are A, B and A. So all these, now if you come to these A subgroup elements, they are the normal elements, and all these B subgroup elements, they are placed in between S block and B block. They are these elements, they are highly electropositive metals. Because of their electron configuration, all these elements, they exhibit variable valency. They exhibit variable valency states. They exhibit variable valency states. What valency? What do you mean? What variable? Variable means what? Which goes on changing, which can go on changing. That is called variable. The market is a variable market. Today you go the brinjal, you will have 22 rupees. Tomorrow you go 25. Next day you go 15. So nothing is there. It goes on changing because of the production, because of the communication, because of other abstractions. Then you have changing. So variable means the which goes on changing is called variable. But there is no definite about it. So all these elements, are transition elements. when we will read periodic table, we'll have a special classes on periodic table. There I will teach you the D block elements periodic table. There I can better explain you. But now I am using the concept of periodic table and go to all these elements. They exhibit variable valency. All these D block elements, they are highly electropositive metals. They exhibit more than one valency state. That is because of their what is called electron configuration. Because of their electron configuration in d orbital. So all these elements, they have degenerate electron configuration. They have incompletely, all these elements, or you can say atoms of all these elements, have incompletely filled degenerate d orbital configuration, degenerate d orbital configuration. Hence they exhibit this variable valency. Please remember this sentence, keep in your mind. I will be explaining you very nicely when I will be teaching you periodic table. I will explain you this, what is degenerate orbital and etc. But now for your in mind, because all of you are very brilliant students, you have some who come from the CBSE, some of you are coming from the ICSE, and some of you are coming from the BOSE, Odisha board, and all of you are trying to have a dreaming for a career. So whenever you are reading something, we go beyond limit. We go beyond limit and study. All these elements are highly electropositive metals, and they exhibit variable because of incompletely filled degenerate d orbital configuration. They have incompletely filled degenerate d orbital configuration. Hence they exhibit this variable valency. Now I'll come to the one example. So the variable I am using here, the configuration atoms of all these elements have incompletely filled degenerate d orbital configuration. Hence exhibit variable valency state. Children, look to this word, variable valency state. I am using here the word variable valency state. Valency and valency state. What is this valency and valency state? I will be explaining you. So what is valency and valency state? So valency and valency state. For example, one simple example I am giving you. Suppose I am sitting in my room and reading. So somebody will see me quiet, composed and all that. I got a news, I won a lottery. I just got a mobile message in WhatsApp. Sir, congratulations. You won the first prize in the lottery, 1 crore rupees. Then I will keep all my books, jump out, come out and take my vehicle and run to the counter to give the ticket and confirm my this. And anybody who comes on the way, he will see I am very much excited. I will jump happy, very happy, smiling, waving, telling I got many things. And in the mobile I will be telling my friends, my relations, my family members. I am very much excited. And I took my ticket and go to the counter. So these, you see, I was very quiet, calm, composed, no reaction in my mind. Now what has happened? I got the news. The news went to me, went to my mind, and I got excited. And now I'm in my excited state. I got the first prize. I went to the counter. He'll ask me, sir, what's your number? I got the first prize. Okay, congratulations, sir. Tell the number. Then I said 2359682. 2359682. Then he will say, sir, again you tell, give the ticket. I gave the ticket. Sir, I'm very sorry. 2359681 has got the first prize, not the 2. No, please see, I got the WhatsApp message by my friend. Yes, your friend might have given the message, and it is 2. All the numbers are correct, but last number is different. My face, which was so much expanded, I was so much excited, so happy, I will immediately reduce. I'll just reduce myself. And anybody who sees me, he'll find me, I'll go very quiet, completely unhappy state. I'll go to my vehicle and sit, not able to start the vehicle. And I will feel, God, how unlucky I am. 2 becomes 1, I lost 1 crore rupees. Think, at that time, now I am composed, excited, now my face. If you have a video recording of my face, you will find I'm self. So this is my state of mind, happy state of mind and unhappy state of mind, and my normal state of mind. Children, the normal state of mind is the atomic state, and these 2 are the combined state. I got combined with a news of happiness. I went to another state. Like I got combined with that happiness. When I got that my number is not correct, then I have gone to unhappy state of mind. You will find reflections of my face. The same mirror will give 3 faces of mine. My voice will change, my action will change, my mood will change. That is, my combination will change. My relationship with immediately they will find the man who was jumping, going out from the college so happily, now returned down and sitting in his room very silently, not talking to anybody. What has happened? So these are my states. These are my 2 states which are not constant, but the middle one is my constant. That is my atomic state, and I have my combining capacity, the valency. And these are my combined state. This is my combined state. Myself plus happiness, and myself plus unhappiness. So atoms also do that. These elements are highly electropositive. They have electrons in their outermost shell. They go to different valence state. They can lose their electron. They can lose their electron and take part in chemical combination very easily in different manner. Hence, they exhibit variable valency state. And they lose electron and combine, so they are very positive. So all these elements exhibit variable, all these D block elements, all D block elements of the periodic table. They are transition metals. All the D block elements of the periodic table, all the D block elements of the periodic table, they are transition elements. They are called as transition elements. They have degenerate d orbital configuration, degenerate d orbital configuration, incompletely filled. They have incompletely filled, so they are d block elements, they are transition elements, and all these are highly electropositive. Highly electropositive means they give electron and become positive. Highly दाता कहा जाए, दाता का को कहा जाए, जी दिए सी हला दाता, जी निए सी हला ग्रहिता. सपोज मते जने बुक गिफ्ट करिवे, दान देवे, ताहले मु ग्रहिता हली सी बहिर, जी बहिटा को देले मते सी हले दाता हले, आ बहिटा हला मोर से जिनसटा हला मोर आम भितरे दीटा रिलेशन करदेला, मते ताकु दाता करदेला, मते ग्रहिता करदेला. So here he is giving and I am taking, same book. So here also same thing, they are highly electropositive because they give electron, so they are called electropositive. They give electron and become positive, because what I told you last class, that A is an atom. In atom, number of electrons are equal to number of protons. Hence, the charge of the atom is 0. The moment the atom gives an electron, it forms a positive charge. A positive charge. Could you understand this? Atom is electrically neutral, no charge, because the number of electrons are equal to number of protons. But here, we lost an electron. This forms a positive ion. So this is called positive valence state. And this is the atom of the element. Suppose another atom is there. Suppose B is an atom which takes electron. Number of electrons are equal to number of protons. Now one electron is increasing. So this becomes B minus. And this is the negative valence state. Negative valence state. And this is also atom. In the atom it is 0. But when it takes electron and combines, it becomes B minus, negative valence state. Hence the B is called electronegative element, and this A is called electropositive element. Electropositive element. I have been telling you children that language is the best thing which gives us the understanding. So these are the language of chemistry: electropositive, electronegative. Those atoms of the elements give electron, take part in chemical combination, form positive ion, are called as electropositive elements, exhibit positive valence state. And all those elements, atom of the elements, they take electron, form negative ion, electronegative ion. They are called electronegative elements. They exhibit electronegative valence state. So they exhibit electronegative valence state. So I am coming to D block elements. They are transition elements. They are metals. They are highly electropositive, means they will give electron and take part in chemical combination. Hence they exhibit positive valence state. And that positive valence state is variable. So very commonly known elements I am writing. There are so many elements. If you come to the periodic table, in the 4th period, we have the first transition series of elements, the scandium 21, titanium 22, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, copper 29, zinc 30. If you go to you look to the periodic table, I have given you the periodic table in last class. Now you have in your screen or you have in your book. Look to the 4th period of the periodic table. 4th period starts with potassium 19, then calcium 20. They are normal elements, S block elements. They are electropositive metals. Now they will exhibit only normal valency, potassium 1 and calcium 2. Now if you come to scandium 21, then titanium 22, vanadium 23, chromium 24, then manganese 25, iron 26, cobalt 27, nickel 28, copper 29, zinc 30. These 10 elements, they are called the first series of transition elements. They are highly electropositive metals. They exhibit variable valence state because they have incompletely filled degenerate d orbital electron configuration. They can easily lose electron and change valence state, take part in chemical combination. So I am coming to a very common element, iron. The iron symbol is Fe. Iron symbol is Fe. So this iron exists in 2 states, Fe plus 2 and Fe plus 3. It can form plus 2 valence state, take part in chemical combination, and plus 3 valence state, take part in chemical combination. So it is a higher state. Which one? 3 is a higher state, 2 is a lower state. So higher state, when there is a higher state, when you have higher state, its name ends in IC. Its name will end in IC. When in lower state, the name will end in OUS. So it is iron. it is a ferrum, F-E-R-R-U-M, ferrum, and ferrum. So this ferrous, this Fe plus 2 is lower, Fe plus 3 is higher, so it is called ferrous. Ferrous, and is a higher state, this is called as ferric. So children, wherever I see, if it is IC, last words are IC, it is a higher state. Last word is OUS, it is lower state. It is always lower state. Similarly, when you come to very common use elements, I am writing mercury. Mercury, it is symbol is Hg. Symbol is Hg. So it can be exhibiting Hg plus 1 state and Hg plus 1 state, lower state, and plus 2 state. It is called mercurous. C-U-R-O-U-S, mercurous, and Hg plus 2, it is called mercuric. It is called mercuric. So when this mercury exhibits two valence state, mercurous and mercuric. Now if you come to another one, you come to gold, Au, gold. This gold, Au is gold, and this exhibits plus 1, Au plus 1 and Au plus 3. Au plus 3. Now if you come to copper, so Rs, this is called Rs, and they call auric, Rs and auric. Now we'll come to copper. Copper, its symbol is Cu, and it exhibits two valence states, Cu plus 1 and Cu plus 2. I'm not saying valency, I'm using this what? Valency state. Means it loses 1 electron, take part in chemical combination. It loses 2 electron, take part in chemical combination. So this is called cuprous. OUS 1, OUS 2, higher IC, cuprous. Cuprous, this is called cupric. This is called cupric. Like this, they are exhibiting the variable valency. Now we'll come to chromium. Chromium. Atomic number chromium 24. In the periodic table you see atomic number 24. This element exhibits a number of variable valence states. It exhibits plus 1, plus 2, plus 3, plus 4, plus 5, plus 6. So why not 7? Because it is 6b of the periodic table. If you look at the modern periodic table, it is 6b of the periodic table. Group number indicates the highest valence state. So 6. Chromium. Similarly, you come to manganese. Manganese, Mn 25, atomic number 25. It exhibits plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. Plus 5, plus 6, plus 7. You see 7. And here higher is 7. Why? Now this element, manganese, is in the 7th B of the periodic table. And this is 6b of the periodic table. How nicely the periodic table is telling us the valence state. I told you the group number indicates the higher valence state. And in chromium, these two are the most used valence states. Most used valence state. Always they use chromium combines with plus 3 state and plus 6 state. And if you come to manganese, it uses generally plus 2, plus 4 and plus 7. We have so many dresses in our house. In our almirah, we have so many dresses. But there are a few shirts and pants which always we use, and all other they remain for the functions. So they are normal, and they are casual. So here also normal, always. What is normal? Which is always. He sees his normal behavior. Means he behaves like that. So this chromium exhibits generally, plus it also exhibits plus 2, plus 3 and plus 6. Manganese exhibits +2, +4, +6. It can be +2, +3, +4, +5, +6, +6, +7. It will exhibit like this. They can exhibit this. Cobalt. If you come to iron, manganese, iron, I told you iron I have written. Iron also exhibits this iron, Fe, atomic number 26, +2, +3, +4, +6. But generally it is exhibiting +2 and +3. It is also exhibiting +3 oxidation state. If you come to cobalt, 27, atomic number 27, +2, +3, +4, +5, +6. So generally it exhibits +6, +3, +2. These are the states it exhibits. So don't get confused. Don't get confused. Only you try to understand the elements belonging to D block of the periodic table are called as transition elements. They are highly electropositive metals. They exhibit variable valency state. They exhibit variable valency state. So this is the way, this is called what is called valency, normal valency state and the variable valency state. So there are so many elements. So you will be reading periodic table, you will be reading atomic structure, you will relate your atomic structure, electron configuration, we will be teaching you, and from the electron configuration we will come to the valency, periodic table, everything we will read very detailed. Now we are only reading the language. Children, don't get confused, don't try, go on reading once, twice, thrice, 4 times, 5 times, you see that becomes your habit. And then now I will come to what is a valency and valency state. Valency and valency state. Valency is a number, does not have any charge, but valency state, it can be positive, it can be positive, it can be also negative. When it will become positive, when the valency state will become positive, it is a positive valency state, positive valency state, positive valency state. When it is, now when atom loses electron to take part in chemical combination. In chemical combination. So this is the element, positive valency state. Now when you got negative valency state, when the atom gains or accepts electron to attain octet, it will exhibit negative valency state. It will exhibit. Who are they? Group 7 elements. They are the negative valency state. Group 6, they exhibit negative valency state. Group 5, they exhibit negative valency state. But if you come to group 1 and group 2, they will never exhibit negative valency state. Why? Now all group 1 elements have 1 electron. They can give that electron and become octet, nearest inert gas structure. Group 2 elements, they have 2 electrons in their outermost shell, they lose 2 electrons. So they exhibit valency 2 and they exhibit valency +2. Valency state is +2. And if you come to group 3, boron, aluminium, gallium, indium, thallium, they have 3 electrons in outermost shell, they can lose 3 electrons and attain octet. So they exhibit positive valency state. But group 4, they can lose, they can gain. Group 5, they have 5 electrons, they can lose 5 electrons, take part in combination, exhibit positive. But they can accept 3 electrons and take part in chemical combination, they will exhibit negative. So they will have positive valency state, negative valency state. So if you come to group 6, Now if you come to group 6 electrons, they can take 2 electrons. They have a tendency to take, so they exhibit negative valence state. And group 7 elements, they have 7 electrons in their outermost shell, so they have -1 valence state, and they take part in chemical combination. So these are all about, and the elements belong to D block of the periodic table. They are having incompletely filled degenerate d orbital configuration. They can easily degenerate means they are identical in their shape, size and energy. Identical shape, size, energy. So they can give electron very easily, take part in combination, and they exhibit variable valency. So they are highly electropositive metals. So this is the way we decide about valency. Now we'll come to the next one, very important one, word that is necessary for a student of science, because I have been telling you, my friends, that if you understand the words, language of chemistry, then you can understand. Like one thing, your teacher will teach you gas law. There he will tell you the gas molecules are moving at random in all possible directions. One word I am telling you, this is a very peculiar word. You see, I am telling you the word, the gas molecules are moving at random in all possible directions. Random. So you'll ask, sir, what is random? Generally people will say, na chaotic. Random kono na yad itastata. Ita ଓଡ଼ିଆରେ ଆମେ ସଂସ୍କୃତ ଇତା ଏପଟେ ସେପଟେ ଇଆଡ଼େ ସିଆଡ଼େ ସିଆଡ଼େ ଇଆଡ଼େ ହେଲେ ଅନଷ୍ଟେବଲ୍ ଏମିତି ପଦରେ କହିଦେବ ର୍ୟାଣ୍ଡମ୍, କିନ୍ତୁ ର୍ୟାଣ୍ଡମ୍ ଇଆଡ଼େ ସିଆଡ଼େ ଇତସ୍ତତ କେଓସ୍ କହିବେ ହ୍ୱାଟ୍ ଇଜ୍ ର୍ୟାଣ୍ଡମ୍, କେଓସ୍। ହ୍ୱାଟ୍ ଇଜ୍ ର୍ୟାଣ୍ଡମ୍ ନା ଇରାଟିକ୍, ଏମିତି ସବୁ ଅର୍ଥ କହିବେ, କିନ୍ତୁ ଏଇ ସବୁ କୌଣସି ପଦର ର୍ୟାଣ୍ଡମ୍ ପଦର ଅର୍ଥ ନୁହଁ। ର୍ୟାଣ୍ଡମ୍ ମୋସନ୍ ୱାଜ୍ ଟୋଲ୍ଡ ବାଇ ହୁମ୍? ବାଇ Robert Brown, the scientist. He had the pollen grains in water, and he told one word, he had used the word random, and that word we people chemistry borrowed to explain the movement of our molecules. The molecules are moving just like the pollen grains, they move inside the water. If you put the pollen grains in water, they go up, come down, go left side, go right side, they undergo collision, all these things happens. So he used the word, he went on to English encyclopedia and wanted to find a word called random. He used the word random and to explain this. Then what is this random? The gas molecules are having random motion. Gas molecules are having random motion. Then what is the random? So to me, if a student will ask me, what is random motion of molecules? Random motion of molecules. To me, random, if someone asks me what you mean by word random, I will say they come and go. They come and go. Ascent and descent. Ascent and descent. Then what they do? Stop not. They will not stop. While going they will not stop. While coming they will not stop. While going up they will not stop. While going down they will not stop not. Then what they will do? Repeat. They will be going on doing it. Repeat. Search, to and fro. To and fro. Elastic motion in all possible directions incidentally. Children, you see one word, so many words I am taking to explain. One word. If this is a boy of science, chemistry, who is reading gas laws, he understands the random motion. All the properties of the gas molecules are because of random motion. All the you just burn a sandal stick. धूप काठटे आम गोटे जगह जलई दौचु घरटा गम 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 बास्ना होची केमती होची ना बिकॉज ऑफ रैंडम मोशन ऑफ द गैस मॉलिक्यूल्स. जदि किसी खराब जिनस गोटे खराब गंधर स्मेल बासना जिनस रहीगला होल घरटा गंधी जाऊँगी बिकॉज ऑफ रैंडम मोशन बिकॉज ऑफ रैंडम मोशन सो ये जो रैंडम पदर देन व्हाट इज दिस आपको यदि डायग्राम रे मदन को सर आप हमको डायग्राम करके बुझातु ताहले व्हाट इज दे कम गैस मॉलिक्यूल मॉलिक्यूल रे दे कम ए मॉलिक्यूल टा आसीबो एमती एठी आसी गला दे कम एंड गो आउ थरे पछू पळेला सीधे जीवनी तळकु जाई पारे ऊपर जाई पारे दे कम एंड गो देन व्हाट दे डू असेंड ऊपर को उठिवा असेंड देन डिसेंड तळु गला डिसेंड स्टॉप नॉट ना एठी रहिबो 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 स्टॉप नॉट देन व्हाट विल डू रिपीट then you will repeat means again it will come and go then ascend then descend stop not repeat such to and fro motion incidentally अर्थ कोन ना अनवरत भावे अविराम गति रे incident will not stop for all time to come of always it will doing it incidentally in all possible directions so if you go to east you will find oxygen if you go to west you will find oxygen if you go to north you will find oxygen if you go to south you will find oxygen if you go to all the four corners जो आम ईशान्य कोण आम पढ़ुचु कि नैऋत्य कोण पढ़िलु आग्नेय कोण पढ़िलु नैऋत्य कोण पढ़िलु वायव्य कोण पढ़िलु 8टा 4टा दिग हला 4टा कोण हला तापर ऊपर उपरू गलु आम तलू आसिलु आमर 10 दिग बोली कह जाए आम तो पूजा करुचु 10 दिग को पूजा करुचु आम से 10 दिग को पूजा करुचु 10टा जिनस अच्छी ऊपर अच्छी तल अच्छी 2 4टा दिग अच्छी 4टा कोण अच्छी 8 एक्जेक्टली एवरीवेयर यू विल फाइंड ऑक्सीजन एवरीवेयर यू विल फाइंड नाइट्रोजन एवरीवेयर यू विल फाइंड कार्बन डाइऑक्साइड बिकम रैंडम इफ यू अंडरस्टैंड दिस रैंडम मोशन दे विल अंडरस्टैंड द गैस लॉस the temperature increases volume decreases temperature increases the pressure increases volume decreases then temperature decreases volume increases all these things you will understand Boyle's law Charles' law combined gas law equation ideal gas equation van der Waals equation if you do not understand the word random then everything is random for you children when I am using the word valency I am using the word valence state I am using the word combination I am using the word combined state they have a meaning for that I am using so please go through these letters go through these words and understand so now taking this one example I gave you so that is called language a person who is very good in his language he will have a very good understanding he will have a very good imagination he will have a very good imagination जदि गोटे छोट एग्जांपल तुमको मु देबी केमती ना देख जने ओडिसा रा पिला अछि पूरी बोली जदि कोई उच्चारण कर देला ताहाले संगे संगे ताको पूरी मंदिर देखा जीवो नील चक्र देखा जीवो आउ जो बाना देखा जीवो आउ जगन्नाथ बलभद्र सुभद्रा देखा जीवे आउ सुदर्शन महाप्रभु देखा जीवे चतुर्धा मूर्ति देखा जीवे आउ आमर महासागर आमर जो अच्छी समुद्र देखा जीवो हमको यहाँ पूरी बोले ओडिशा पिला को यह लगिला किंतु पूरी यदि इच्छापुर पलैल कि पलासा पलैच कि श्रीकाकुलम पलैच आंध्र प्रदेश को पलैच से पिला मानक कह पूरी कहले सी कह ना राउंड राउंड सॉफ्ट सॉफ्ट से कह पूरी माने पूरी खाइबाटा पूरी पूरी से देखा पूरी देखा आउ बढ़िया वेरी गुड टेस्ट he will tell the puri you are telling wonderful very good state it is a breakfast I always take he will tell but the puri ओडिशा पिला को आसिला को भगवान नीलाचल निवासाय नित्याय परमात्मने बलभद्र सुभद्राभ्याम जगन्नाथाय ते नमः ये कहला कहब ये हाथ जोड़ी की प्रार्थना कला बेलू तेलुगु पिला कहब खाइबी केमती बोली कहथो से सो दिस इज द मीनिंग ऑफ द वर्ड पूरी स्पेलिंग समान सबु समान किंतु अंडरस्टैंडिंग इज मीनिंग सो चिल्ड्रन यू हैव टू यूज द वर्ड्स अंडरस्टैंड द लैंग्वेज and once you understand the language the sky is the limit for you so read in between the lines first line or second line ta bhitare jo gap ta rahila that is called the gap of knowledge you have to understand all the words and understand the next words then you can understand very peculiar valence state valence is the word combining capacity से केते कंबाइन करि पारिबो केतेटा कंबाइन करि वैलेंसी किंतु वैलेंसी स्टेट से जो 5 अच्छी 5 रु केते यूज करिछि हाउ मच यूज्ड which is he has used, so that is called valency state. So valency state को जदि इलेक्ट्रॉन नहीं की कंबाइन करुछि ताको हमें इलेक्ट्रोपॉजिटिव एलिमेंट कहिबा valency state is electropositive valency state. जदि इलेक्ट्रॉन नहीं की से कंबाइन करी ऑक्टेट हेछि ताले हमें कहिबा इलेक्ट्रोनेगेटिव valency state. And the element is called electronegative element. The element is called electropositive element. You see, if you understand the word valency, you are understanding the word so many means. So this is the valency I have told you. Next class, I will be talking to you what is radical. You understand the valency, what I have told you. I have one class I have already done. 2 classes I have done on valency. Next class, tomorrow, I will go for you what is a radical. So you read your book, radical, and many things you will be following that. Many doubts will come to you. I will be explaining the word meaning radical and what are the different type of radicals and how taking the knowledge of radicals we will write the formula, and if you do that then balancing chemical equations we will do, and that will be the most easiest way we can balance all the chemical equations. Unless we understand these words, all the balancing equations, there also you have to remember, we will not remember anything, we will only forgetting लाखों ही तेरे पीछे लेकिन तू मेरे पीछे is a hero. लाखों ही तेरी पीछे तो पछरे लक्ष्य लोक किंतु तू मो पछरे because I am the hero. You will become a hero of the chemistry then when you understand the language of chemistry. I wish you all best and go through the words, try to understand. Thank you so much my dear students for listening so nicely.